Okay, so our lesson today is called improper integrals. And we've probably can recall touching on this before, this idea before. It might look a little familiar. What we're doing is just using an integral to find the value of this shaded region's signed area here. So if I was to set this up, I would be going from A to B here. What they're talking about with this like arrow, what I've shown in this picture, is that I'm actually trying to get the value of this area as we just go to infinity. So B is just going to infinity, which would be finding all this little area forever. So it would make sense to use this kind of idea of going to infinity if you kind of reach some kind of asymptote, getting closer and closer to zero. So I would set up my integral like this, from a to infinity of f of x. But here's what's happening that makes this improper. There's an infinity here that is supposed to be a number, and we technically can't say that we're going to infinity because you can't actually go to infinity. There is no number of infinity. So this would be improper to say. So anytime you are plugging in infinity as one of your upper or lower limits of integration, that would be considered an improper integral. Now we could still solve it and like do the work on this, but in a free response question on the AP Calculus test, they would not like to see you plug in infinity. So instead, the idea is to make it proper would be to say, let's put it as a B, from A to B, but to simulate going to infinity for that B value, we can use limits and say that B is approaching infinity. That's different. You can't actually plug in infinity, but you can approach infinity, and then that makes more sense. Now, this is proper, so this would be proper. And then if you were to continue doing this integral, the steps of the fundamental theorem would be to first to anti-derive this function. That would give you capital F of x. And then you would draw your bar from A to B, but we'd still have to write the limit as B goes to infinity on that. Then the next step would be to plug in the top minus the bottom, but you got to write B in there. So it would be F of B minus F of A. But since B, you can't just put infinity in, it wouldn't be proper. You have to put the limit, you got to keep writing that limit. So this technically makes mathematical sense to say as B goes to infinity. All right, so all this really is just like a matter of technique of writing to prevent us from putting infinity up here and writing it as a limit instead. So let's go ahead and try some of these problems.